Motion and forces. Chapter number 3, numerical problems. Problem number first. An object travels 60 meters in first 6 seconds, then keeps uniform motion for next 9 seconds. In the last 10 seconds of the journey, it decelerates uniformly to rest. Find the maximum speed attained in the journey and total distance traveled in the whole journey. First, we will determine part 1 of the problem, which is maximum speed attained in the journey. So, according to the problem, the object starts traveling from origin O. In the first 6 seconds, it travels 60 meters, and the next 9 seconds, it keeps uniform motion, which means constant velocity with no acceleration, and in the last 10 seconds in this journey, it decelerates to rest from that uniform velocity. This is the decelerating phase. This is the uniform velocity phase, which means the velocity does not exceed from the maximum. We will determine the maximum velocity from part 1 of the problem during the first 6 seconds journey. To do this, we will need acceleration. To find the acceleration in this 6 seconds journey, we will use second equation of motion, which is distance s is equal to vit plus half at square. The distance in the first 6 seconds journey is given as 60 meters. We put the value of distance s as 60. The object starts its journey from rest, which means the initial velocity of the object is 0 plus 1 over 2 at square. T is given as 6 seconds. We put the value of time t here and determine the acceleration a. 60 is equal to 6 are 36 divided by 2, which is equal to 60 is equal to 18a, and a is equal to 60 divided by 18, which in turn results in 3.33 meter per second square. Now we know the acceleration. We can determine the final velocity in this journey. To determine the final velocity, which will be the maximum speed attained during this journey, we used first equation of motion, which is Vf is equal to Vi plus At. Again putting the values in this equation, now we know the acceleration, we know the time, and we know the initial velocity s, which is initial velocity is 0 because the object starts its journey from rest. 0 plus 3.33 meter per second square multiplied by 6 seconds, which is equal to Vf is equal to 20 meter per second, and this 20 meter per second is the maximum speed attained during this whole journey. Okay, now here we solve part B of the problem, the total distance traveled in the whole journey. Total distance traveled in the whole journey will be equal to the sum of distance traveled during the first phase of motion of 6 seconds from 0 to A plus the distance traveled from point A to B and plus the distance traveled during the third phase of the journey from B to C. We know that the distance traveled during the first 6 seconds is given as 60 meters. Now we determine the distance traveled in the second phase of the journey in the next 9 seconds. Here the velocity of the object is uniform. We use simple equation V is equal to S by T, which is S is equal to V multiplied by T, velocity multiplied by time, and the velocity which we have determined in the previous section is 20 meter per second. Velocity is 20 meter per second and the time is 9 seconds. 9 multiplied by 20 is equal to 180 meter. Now we need to determine the distance traveled during the journey from B to C. To do this, we will again need the acceleration value because this is the decelerating phase. In this phase, the object decelerates from the constant velocity of 20 meter per second to 0. We use first equation of motion, which is Vf is equal to Vi plus At. Here the final velocity will be 0 because the object stop at the final position, and we will use the initial velocity as 20 meter per second plus 80. Here we will determine the A and the time t is 10 seconds. Putting these values in this equation, the equation becomes 0 is equal to 20 plus A multiplied by 10, which is equal to A is equal to minus 2 meter per second square. Now we know the acceleration. We can determine the distance traveled during this journey from B to C using third equation of motion, which is 2as is equal to Vf square minus Vi square. Here we are going to put the values and determine the distance traveled during this phase of the journey, which is BC is equal to S is equal to Vf square. The Vf value here is the final velocity will be equal to 0, which is 0 square. The initial velocity will be 20 meter per second. So putting the value for Vi is equal to 20 meter per second square 2, and the acceleration is minus 2 meter per second square, which is equal to, this equation will become minus 400 divided by minus 4, which is equal to 100 meters. Now to determine the total distance traveled in the whole journey, we put these values 100 meter, 180 meter and 60 meter in equation number 1, which will be equal to d total distance traveled is equal to 60 meter plus 180 meter plus 100 meter, which is equal to 340 meters, which is the final results. Thank you for watching and don't forget to subscribe.